Watching this video, chances are you're probably wondering why the Atlantic and Pacific Oceans meet but never mix. Well, here it is. So we know where the oceans meet. Now we can move on to something a little more technical, the question of whether or not they mix. This may seem like an odd proposition. After all, they are both waters, so surely they should mix. Well, it's not quite that simple. Due to the different densities and currents of the two oceans, they don't disperse together calmly and evenly. The Atlantic is saltier than the Pacific, which makes the water denser, creating the rough border along the sea. So why do the two oceans not mix? The reason for this strange phenomenon is due to the difference in water density, salinity, halocline, temperature, thermocline, and current of the glacial meltwater and offshore waters of the Gulf of Alaska, making it difficult to mix. So let's look at each of these factors. Density. So you may want to ask, how can the two oceans have different densities if they're both waters? The difference in their densities is a function of varying salinity concentration and levels of temperature. Density is expressed as mass over volume, which implies that density is directly proportional to mass. And when you put more salt in water, the density of that water increases because of the mass of the water increases. So let's do an experiment. Take two samples of water with the same volume but different salinity levels and add some egg. What do you notice? The water sample with more dissolved salt will make the egg float better than the other, as water with higher salt concentration will be more dense, making it difficult for both to mix. That explains to a large extent why the Atlantic and Pacific Oceans never mix. In this picture, you can see the major current movements of the two oceans. Notice their differences in color. The sky blue color is typical of a shallow tropical shelf Atlantic current, while the deeper water Pacific current looks dark blue that never gets mixed.
Halocline. There is a term in oceanography which is called halocline. It is a subtype of chemocline, which is a cline, or a comparatively thin, typically horizontal layer within a fluid in which a property of a fluid varies greatly over a relatively short vertical distance. The halocline always has a different level of salinity than the surrounding water, and so the two bodies of water actually stay separated. Some examples of haloclines are the Strait of Gibraltar, where the Mediterranean Sea and the Atlantic Ocean intersect. These two seas in essence are recognizably different from each other. The Mediterranean Sea is moderately warm and its saline content is less dense than the Atlantic Ocean. When the Mediterranean Sea water enters the Atlantic Ocean over the Gibraltar Shelf, it moves several hundreds of miles into the Atlantic at a depth of about 3,300 feet, with its own warmth and its own less dense characteristics, and it forms a horizontal halocline that can easily be seen on the surface, such as the rare vertical barrier in the Alaskan coastal area, and also Skagen, Denmark, which some say almost looks like the Great Wall of China. Skagen is the northernmost point of Denmark where the Baltic Sea and the North Sea meet. Both of the opposing tides here cannot merge together because they have different densities in chemistry. Some more extreme examples of haloclines can be seen where the Rio Negro and the Amazon River meet in Brazil. The Amazon is silty, while the Rio Negro looks like dark tea due to its high concentration of organic constituents of soil, minerals, and vegetation.
Good evening, everyone. Now that everybody has watched that and you understand the difference between the freshwater and the saltwater and the density between the two, now it's my turn. Here's what I want you to understand. You see how this water separates? Two different oceans separate perfectly. And it's always there. Always there. In these different spots of the world, you will find this. And I couldn't remember the verse in scripture, so I had to research it real quick for you guys, and here it is. 19. He has let free the two bodies of flowing water, salt and fresh, meeting together. 20. Between them is a barrier which they do not transgress. 21. Then which of the favors of the Lord will ye deny? Okay, now you see that in scripture? Perfect description. Salt and fresh, where the two bodies of flowing water separate, meet together. Okay, now here's my point. When you don't want to believe the Bible and you don't want to believe any of this stuff, some guy sitting in a desert 3,000 years ago, nowhere near the ocean, just sat there and wrote where the two bodies of flowing water, salt and fresh, meeting together. Between them is a barrier which they do not transgress. Think about that. A guy sitting in the desert 3,000 years ago wrote this. That's why he's called a prophet. But even aside of biblical scripture, here's what I want you to understand and comprehend common sensely. These two bodies of water are perfectly divided in every single one of these spots all over the world, always has been. If the earth were a spinning globe, spinning 1,000 miles an hour, these waters would be all over the place, but they're not. They separate in the same place. All over the world, you can go see this. They're always in the same place. Always been there. Now go in the kitchen and fill a third of a cup up with water and then another third with vegetable oil. They're separate. But you spin that cup and I'll guarantee you they'll mix together. But when you stop spinning that cup, they'll separate again. Do you know why? Because density can't happen in liquid spinning 1,000 miles an hour. It has to be a solid liquid, still, stationary, in order for density to work. And this right here, here's your proof right here. Anytime you want to, you take a boat out here, you take a helicopter out here, and you can see it with your own eyes. I'm showing it to you guys right now. Check it out. Any time of the year, these two waters never mix together. This can only happen on a flat and stationary earth. Get right over the center so they can see it perfectly divided. There you go, right over the center. Now, as you can see with your own common sense, this can only happen on a flat earth. Like I said before, if it was a ball of spinning water, all this stuff would mix together. It's all perfectly divided. You know why? Because the earth is flat. Everyone, thanks for watching. Have a good night, and God bless.